Hello everyone, my name is Dr. Arya S. Welcome to today's session on indifferent curve analysis. In this class, we will explore how consumers make choices between different goods to maximize their satisfaction. Let us start with the concept of utility. Utility simply means satisfaction a person gains from consuming a commodity or service. Simply satisfaction from consumption. It also can be defined as power of the commodities or services satisfying human wants. So, utility means satisfaction we gain from a particular product or power of the commodities satisfying human wants. Economists have used two approaches for measuring utility. First one is cardinal utility approach and second one is ordinal utility approach. First, we are looking into the cardinal utility approach. According to this approach, utility is considered as a quantifiable entity or measurable entity. It assumes utility can be measured in terms of numbers. Like we are saying, a cup of coffee gives 100 utils of satisfaction to me. Okay, util is the unit we mostly use it to measure utility, cardinal utility. For example, for a coffee addict or a coffee lover, uses 100 utils of satisfaction or gain 100 utils of satisfaction from one cup of cappuccino, while a cup of tea gives him only 50 utils at the same time. So, here we can say how much, according to cardinal utility approach, we can say how much satisfaction, how much unit of satisfaction we gain from a cappuccino or tea or any other commodity we consumed. Next one is ordinal utility approach. Here, utility is not a quantifiable entity. Okay. Here, we can only rank or arrange consumer preference in an order. And it can be understood using the indifferent curve approach. And this indifferent curve approach popularized by the J.R. Hicks and R.J.D. Allen in their paper A Reconsideration of the Theory of Value in 1934. And this ordinal utility approach, we say that consumer preference can be arranged in an order. Okay, as a coffee lover, I can say that I prefer coffee to tea and tea to milk. So I like coffee first. My first preference. If these three options are available, I like to prefer coffee. First preference is coffee. Second, as a coffee addict or coffee lover, my first preference is coffee. If these three beverages are available, coffee, tea and milk, I like to opt coffee to tea and milk. Utility gain from coffee is greater than tea and milk. So my first preference is coffee, second preference is tea and third preference is milk. So I can rank it like first, second, third, but I cannot say I got this much of utils from coffee or tea or milk. So just simply I can arrange it in an order based on my preference. Now we are formally looking into formally going to discuss indifferent curve approach. Indifferent curves. Indifferent curves. J.R. Hicks used the concept of indifferent curve to analyze consumer behavior based on ordinal utility. Okay, but this indifferent curve was introduced by the Edgeworth, and Hicks used it to explain consumer behavior. Okay, so now we going to discuss what is indifferent curves. How can we define it? Okay, indifferent curve can be defined as the locus of points showing different combination of two goods that yield same level of satisfaction. This is the indifferent curve. Okay. It is the locus of point. These all are the points. Okay. These line represent point. That is, it's a locus of points showing different combination of two goods. Here, good X, good Y. So it is the combination of two goods and this all points, that is different combination of two goods that showing same level of satisfaction to the consumer. Okay. So any combination of goods consumer taken from this particular curve or this points, it gives same satisfaction to him. So he will consume in this point or this combination of goods, this combination of goods, all these points, all these combinations of goods, this IC1, this all this combination of goods in IC1 curve give him same level of satisfaction. For example, K. So whether it is this point, this point, this point, I got same level of satisfaction. So if it was me, I was indifferent between all these points because I get same utility or same satisfaction from this curve or from the all points in this curve. So I am indifferent between all the points. So indifferent curve is the locus of points showing different combinations of two goods that yield same level of satisfaction. This box or this table give indifferent schedule of two commodities X and Y. The table 1, we can see in this table, we can see 5 different combinations of tea and biscuits. Like commodity X is tea and Y is biscuits. So here at the combination A, there is 1 unit of X and 12 units of Y. But in second combination, in B combination, 2 units of X, 8 units of Y. But all this combination, whichever it is, A, B, C, D or E, all this combination give same level of satisfaction to the consumer or equal level of satisfaction to the consumer. Okay. Here consumer is indifferent between all this combination, all these points, or whether he buys. So consumer is indifferent whether he buy 1 unit of X, 12 unit of Y, 2 unit of X, 8 unit of Y, 3 unit of X, 5 unit of Y, 4 unit of X, 3 unit of Y, 5 unit of X, 2 unit of Y. All these points give him same level of satisfaction. It is the graphical representation of the last table. It shows the combination of good X and Y, A, B, C, D, E, which will equal level of satisfaction to the consumer. Okay. So whichever the point, I say I, J, K, L, M, N. All the points in this curve or all the points in this IC1 curve provides equal level of satisfaction to the consumer. So I am indifferent in each point. In every point I am indifferent. I got equal level of satisfaction from all the points in this indifferent curve. Okay. And another point you should keep in your mind, in normal cases, in most cases, indifferent curve is downward sloping and point of origin. In normal cases and in most cases, we can say that indifferent curve is downward sloping and convex to the origin. Some exceptions we can note it in perfect complements, perfect substitutes, etc. So some perfect complements, perfect substitutes, etc. So some cases there is a change in the shape of indifferent curve, but in most of the cases in normal good, indifferent curve is downward sloping and convex to the point of origin. Another important concept in indifferent curve is marginal rate of substitution or MRS. Okay, it also known as slope of indifferent curve. Slope of indifferent curve. Indifferent can shortly depict as plot as IC. So marginal rate of substitution is the slope of IC or indifferent curve. So how can we define this concept? Marginal rate of substitution represent amount of one commodity Y the consumer is willing to sacrifice for the gain of an additional unit of X so that his satisfaction remains same. We know that we have limited resources, okay. So in order to get an additional unit, we have to reduce the consumption of other goods. So marginal rate of substitution represent amount of one commodity Y the consumer is willing to sacrifice for the gain of an additional unit of X so that his satisfaction remains same. Okay. Here we so that ABC 1 unit of X, 2 unit of X, 3 units of X, 12, 8, 5. Okay. Here in order to get an additional unit of X, we have to sacrifice 4 unit of Y. In order to get extra addition, we need to sacrifice 3 unit of Y. So here marginal rate of substitution says rate at which one commodity is substituted for other commodity, or amount of one commodity a consumer is willing to sacrifice for the gain of an additional unit, but keep in mind so that his satisfaction remain the same. The equation of MRS is delta y by delta x. Change in y2, change in x is the equation of MRS xy, marginal rate of substitution x to y, okay, xy. And convexity of the indifferent curve. We discussed that indifferent curve in most cases is downward sloping and convex to the origin, and its convexity of the indifferent curve represent the diminishing marginal rate of substitution, which we will discuss in the later portions. Now, we look into the properties of indifferent curve. Properties of indifferent curve. First property of indifferent curve is it is a downward sloping curve from left to right. Okay. It's a downward sloping curve. This is an indifferent curve. IC. It is a downward sloping curve. Why is it downward sloping curve from left to right? It is because if you increase the quantity of one good, you must reduce the other to maintain the same level of satisfaction. Okay. If you increase the quantity of one commodity, you must reduce consumption of other. Good. Okay. So that is why, that is A, B, C, D, E, 1, 2, 3, 4, 5, 12, 8, 5, 4, 3, 2. Okay, here in order to get an additional unit of x, I have to sacrifice 4 unit of y. Okay, when it comes to the C, combination C, there are 3 units of the x. For get an additional unit, here I have to sacrifice 3 unit, then 2 unit, then 1 unit. So, if you increase the quantity of one commodity, here x, you must reduce the quantity of other to maintain same level of satisfaction. That is downward. That is because indifferent curve is downward sloping curve from left to the right. The second property is these indifferent curves are convex to the origin. Okay, I said that it is because diminishing marginal rate of substitution, diminishing MRS. Okay. How can we say it is diminishing? We know that marginal rate of substitution is the rate at which one commodity is substituted for another. So, here we can say that as you consume more of one good, less you are willing to give up another. As we consume more and more units of a commodity, you know that you have to substitute other commodity for gaining one additional unit. But here we can say as you consume more and more, 1, 2, 3, 4, but we are less willing to sacrifice the other good. First time we are ready to sacrifice 4 unit, then it become 3 unit, then it become 2, 1. So here, as the consumption of X increases, you are less willing to give up the Y commodity. Okay. So that is why we can say that diminishing MRS, and because of this property, indifferent curves are convex to the origin. Third property is indifferent curves cannot intersect each other. Okay. It is because if two curves crossed, it would mean the same combination gives 2 different levels of satisfaction, which is impossible. We know that a property of indifferent curve is 2 indifferent curves have 2 levels of satisfaction. Okay, 2 levels of satisfaction. Okay, 2 indifference or 3 indifference, all indifferent curves are different. All indifferent curves are different in terms of satisfaction level. Okay, IC and IC2, both of the curves have 2 different satisfaction level. Okay, this IC1, IC2, IC3, all these have 3 different levels of satisfaction. Okay, so we can say that if two curves are crossed, it would mean the same combination gives two different levels of satisfaction, which is impossible. Here we can say that here it is the point B. Let's consider IC1 and IC2. A, point B. We know that according to the first indifferent curve, IC1, A and B are on the indifferent curve, so they have same level of satisfaction. Same satisfaction. Okay. According to IC2, it's C. It's C. C. In IC2, B and C are in same indifferent curve and so same satisfaction level. Here B gives different, the same point, same combination of good, B gives two different level of satisfaction, but it is impossible. One point can give only one level of satisfaction. So here this point B, because if you cross, it will contradict the theory. So different indifferent curves provide different level of satisfaction. So if two indifferent curves cross, same combinations gives two different levels of satisfaction, which is impossible, and it will contradict the indifferent curve concept. The fourth one is higher the indifferent curve, higher the level of satisfaction. We knew that people prefer more good to less good. Okay, so more goods give more satisfaction to the people. So if I get more satisfaction if I have 2 cups of cappuccino or than 1 cup of cappuccino. Okay, so higher the indifferent curve, higher the level of satisfaction. Here this is the lowest one, this is the highest one. Here I have more goods. Okay, here are extra goods, more goods than the IC1. So this IC second curve, the highest curve provides higher level of satisfaction to me. And next property is this indifferent curves do not touch the axis. If a curve touched an axis, it would mean consumer only want one good and none of the other, which contradicts the concept. We know that indifferent curve means it is a combination of two goods that giving same level of satisfaction. Here, if this indifferent curve touches both the axes, it would mean consumer only want one good and none of the other, which contradict the concept itself. So, both of indifferent curves do not touch the x-axis or y-axis. This curve represents indifferent map. Okay, this figure represents indifferent map, which is a set of indifferent curves or groups of indifferent curve. This figure expressed two indifferent curves IC1, IC2. Now let's explore Now let's explore indifferent map, which is a set of indifferent curves or group of indifferent curve. This figure represents the indifferent map, which is the collection of 4 indifferent curves IC1, IC2, IC3 and IC4. And also we knew that higher the indifferent curve, higher the level of satisfaction. So all the points in IC2 will yield higher satisfaction than the points of IC1, and all the points on IC3 will yield lesser satisfaction than the points of IC4. Or the IC4 points, all points in the IC4 gain more satisfaction than points on IC1, IC2 and IC3. Higher the indifferent curve, higher the level of satisfaction. Okay. Now we are winding up our class. Tomorrow or next class we are going to discuss consumer equilibrium, budget line, revealed preference theory, etc. Until then, good night, bye. Now I am winding up our class. Tomorrow or next class we are going to discuss budget line, consumer equilibrium, etc. By then, bye. See you in the next class. Thank you for your participation.